Hello, I'm Zoe Kaufman, publisher and CEO of Truthdig. We'd like to welcome you to our event, Downstream Radioactivity, What on Earth is Coming Out of the Pipes, hosted by investigative reporter and author Justin Noble. This event stems from an article Justin wrote for Truthdig, which highlights new research on the significant amounts of toxic radioactivity emanating from the natural gas pipelines. This is affecting the health of our communities and the environment. Unfortunately, the industry creating this radiation has had little to no accountability. At Truthdig, we're always digging beneath the headlines to bring you stories that are not only provocative, but bring awareness and change. Events like this highlight our commitment to routing out injustices, such as the environmental injustices that will be discussed today. So I'll turn this over to you, Justin, and your esteemed panel of scientists and activists. Thank you.
Thank you, Swade, and thank you, Truthdig. It's really exciting to have independent media active and energetic and engaged on these topics. And I'm just going to give a quick introduction of the people who will be presenting today. We have Dr. Marcia Haley. She will be presenting. She is a radiation oncologist, and I think she's right here, can give a little introduction.
Hi, Justin. Thanks for the introduction. I'm a radiation oncologist and clinical assistant professor at the University of Pittsburgh Medical Center, and I am also active in research for pollution from unconventional drilling and other industries that affect our health and the air, water, and soil. And today I'm going to be talking about some research I was involved in on the topic that we're discussing today, as well as some of the health effects.
Super, thank you. And we have Tammy Murphy with Physicians for Social Responsibility, Pennsylvania.
Hi, I was muted there. How are you? I am Tammy Murphy with Physicians for Social Responsibility. I'm the advocacy director in Pennsylvania, and we deal with a lot of environmental health issues here, and many of them are related to the fracking industry.
Okay, excellent. Thank you, Tammy. And we have Christina DiGiulio also with Physicians for Social Responsibility, Pennsylvania.
Hello, Justin. Hello, everybody. Thank you so much for having me. Christina, or PK DiGiulio. I'm also, as Justin noted, I work for, I'm a consultant, scientific consultant for Pennsylvania PSR PA, and a certified thermographer in optical gas imaging. And I'm also a watchdog, which I will be talking about today.
Okay, thank you, Christina. And we have Dr. Detlef Helmig, who is an atmospheric scientist and an air pollution expert in Colorado.
Yes, hi everybody. Thanks, Justin. Good to be on this call. As Justin said, I'm an atmospheric scientist, and over the last 5+ years, my work is focused on studying air pollution, air quality, emission sources in the Colorado Front Range, and I'll be reporting from one of these sites that we've been operating, where somewhat surprisingly made some interesting observations on airborne radioactivity. Thank you.
Okay, thank you, Dr. Helmig. And Tina Snoods, who is based in Virginia, a former physician and following the Mountain Valley Pipeline really closely.
Hello, everybody. I'm a retired physician who I worked in hospice and palliative care and emergency medicine for quite a few years. And when I retired, I looked around and thought, well, you know, I've always looked out for people's health, particularly vulnerable people. And sure enough, the Mountain Valley Pipeline reared its ugly head. And I decided that focusing on health threats of large fracked gas pipelines was probably something that I could really help with.
Yeah, thank you so much, Tina. And we have Bill Rupert, also based in Virginia, resident, and also focused on the North Valley Pipeline, among others. So.
I've been fighting natural gas pipelines for about the last 7 years or so, particularly the Atlantic Coast Pipeline that directly impacted my wife and I, and the Mountain Valley Pipeline. And I learned about radioactive issues with the oil and gas industry about 3 years ago. Dr. Smooths introduced me to that, and Justin, you gave me a lot of information. So I've been looking at that and also a lot of the other negative impacts from natural gas pipelines. And happy to be here. Happy that Truthdig has sponsored this event. We really appreciate it and hope to get the truth out today.
Okay, super. Thank you so much, everyone. And I'm just going to give a brief introduction now of the topic and really to try and get people ready for the presentations to come. So I'm just going to drop this presentation here. Super, thank you. And went through the list of folks. So really, let's leave it on the first screen for that. So the question here, the issue here is that we have radioactivity coming to the surface in oil and gas development. It's happening in a variety of different interesting ways, a variety of different interesting streams, and it's moving forward through the oil and gas production system. There are industry documents that lay this out in detail, and yet that information has not been presented to the public. And what we're doing today is to spotlight some really fascinating research happening by the scientists, the health experts, the community groups, and residents who just introduced themselves to try and track that, to try and figure out exactly what's happening, and also to present tools and information on how to take findings back to regulators, back to the industry, to hold them accountable on this issue. This is just a visual representation. If you haven't spent much time in oil and gas country, there's a lot more than just a wellhead where the oil and gas comes up. There's a variety of infrastructure necessary to bring the oil and gas through the system, to refine it, and to bring it eventually to a home, to a tanker, to various points of usage, a power plant. And there's emissions all along the way. And a compressor station, which is what's featured here, has particularly copious emissions. People who live in oil and gas country can convey that. Massive amounts of emissions. So what's actually in them? We know a great deal. On some of the contaminants, radioactivity is a new area of focus. And very simple diagram, because in the end, this can be understood with a really simple drawing. We have a variety of things happening at the wellhead. We're bringing the product we want to the surface, the oil or the gas. We're also bringing what's referred to as brine. It's a type of oil field wastewater. Flowback is another type of oil field wastewater. These things are unwanted. They're going to be dealt with by the industry in various ways, and they contain radium, which is a radioactive element that is moderately soluble and can flow up to the surface with the brine. We're not going to be talking about that today. Radium is a really concerning element, and it is then peppered throughout various parts of the oil field. It follows a different pathway. Today, we're going to focus on the radioactivity coming up in the product itself. So in the oil, in the gas. And oil and gas are going to go through a number of systems, again, as they move on through towards refinement and eventually the place of use. So what types of facilities, in particular, talking about natural gas processing plants, that's a place that is processing the natural gas, which is methane, but there's also other light hydrocarbons, other types of fuel referred to as natural gas liquids. And at a natural gas processing plant, the methane is going to be separated from these natural gas liquids, things like ethane, butane, propane, which many people know you use propane at home or if you go camping. Ethane becomes really key in the plastics industry. So we're separating out these different natural gas elements, and they're going on through to other places. And the radioactivity is then going to follow according to different rules of science. So we're looking at compressor stations. We're also looking at petrochemical plants like ethane cracker plants, which are processing the ethane. And we're looking at oil refineries as well, because you have this radioactive gas, radon, which is also in the oil stream as well. Just to go back over that, we have radium, which is the concern with brine, with the oil field wastewater, but with the product itself, with gas, with oil, it's radon. It's a radioactive gas, a different radioactive element, and that's what's following through. And here are slides from an oil field radioactivity industry consultant. I know it is, it's just more believable to see it from an industry expert who's laid it out. And there in the upper right, you can see they've laid out essentially what I did on the previous side, the pathway from wellhead through the various processing steps, and then on towards the home. And talking about radon, and then talking about the different radioactive elements that radon is going to decay into. And I know other speakers will get more into that, but we have radon, and then we have some concerning elements that radon is going to decay into, and they have their own interesting characteristics. Going to another really important industry document, one of the documents that led me into this topic. We have another industry consultant, this one some years earlier, Peter Gray, publishing in two really reputable sources. The first one at the top, the Oil and Gas Journal. The lower one, the Journal of Petroleum Technology, which is the prestigious journal of the Society of Petroleum Engineers. And laying out in what I would say pretty, at least a science-minded publication, pretty easy to understand language, exactly how radioactivity moves through these systems, and really labeling some specific concerns. One thing to note is the term here, norm. This will come up throughout the afternoon. Norm stands for naturally occurring radioactive material, and it's often how the industry refers to this radioactivity that comes up. They'll use another word called T-norm that stands for technologically enhanced naturally occurring radioactive material, and that refers to when the radioactivity is collected or concentrated or manipulated in some way by humans. I would say you should know those words exist, but they're kind of made to make you fall asleep and think this isn't a problem. And so I don't really like to refer to them a lot. Even that they use the acronym NORM, is outrageous to me. Okay, really important issue. If we're following this pathway, we have huge ethane cracker plants coming up across the country and really across the world right now. We have a new one online in Pennsylvania, just outside Pittsburgh. It's already had all sorts of emission issues, but there also are radioactivity issues. There has not been a lot of research on this, but this is a paper I've dug up from Argentina where radioactivity was looked at ethane cracker plants. And just a really quick little point of data here. Radiation at Facility F. Facility F is an ethane cracker plant, and they're looking at the pumps. A pump is something that processes a fluid stream, and so it's natural that at a place like a pump, you're going to accumulate more gunk, and this gunk happens to be really radioactive, and you can see 2,667 times background levels. And just to let folks know, typically, health agencies or the oil industry itself, in some of their documents, they refer to twice background as a contaminated space, 2 times background. Background is the natural radioactivity of a region. We live on a mildly radioactive planet, so there is going to be some radiation everywhere, and we refer to that natural radioactivity as background. Even if we're taking natural elements up from the earth that are radioactive and spewing them out in an area or concentrating them, that's still going to enhance it. And in this case, we're enhancing it really at an extraordinary level. And so the question becomes, we know it's accumulating there in a pump what is coming out in the emission stack at that ethane cracker plant. Here, a really important slide from the industry. I think this slide is so powerful. For one, it's their slide. So they're showing you this is real. And they're showing you really where the concern comes. When a radioactive stream is stuck in the pipeline, it's not really necessarily a risk. It's when you do maintenance, in this case, on the pipe. You see an oil field worker opening it up, and then you're releasing particles that can easily be inhaled or be ingested. And the diagram actually points out really well what happens. They stick in the soft tissue of your lung, which does not have protection against radiation. Even your skin, for example, will have some protection against certain types of radiation, but internal parts of your body do not. So the lung is a horrible place for a radioactive element to be, your gut as well. Another point here, we're opening up a pipe, right? So the industry is telling us when we open up these pipes, there's an exposure risk. So a smokestack is just bringing an open pipe up into the sky and releasing the emission to the wind. And these are the questions some of these scientists and health experts are trying to answer. Well, what happens when you do that? We know if you open it up in the facility, there's certainly a risk. What happens when you release it to the atmosphere just upwind from a community? And the final point I want to make is that this is an international issue. This is a paper from one of the authors is Dr. Mark Bhaskaran, who's of Wayne State University, was involved in one of the studies you'll hear about today. And here he looked in Kuwait at an oil refinery and a number of other settings around Kuwait. The oil refinery was in this industrial complex, and they found radioactive emissions were highest closest to this industrial complex that had the oil refinery. This is just really the beginning of trying to look at what's happening here, but a really important paper that points out, we do seem to have an issue, and certainly more examination is necessary. And the final slide before I hand it back off to the presenters is again highlighting the fact that this is a global issue. This is a really fantastic health advocacy group outside Edinburgh in Scotland. And they are called Mosmaran Action Group. They're looking at, in the bottom, you have a really nice image of it, a facility that has a cracker plant, an ethane cracker plant, and a natural gas processing plant on the same location. And then the top image from their website shows community health notices or messages that people have sent to the group of complaints. So they're pointing out when there's an issue, the specific ailment that they have, what they observed at the plant, and the numbers refer to just how many complaints have come in from that area. So if we go to the next slide, we'll zoom in, and we're zooming in now on these complaints. And you can see these are the types of things people who live next to these facilities observe. Flaring, causing headaches, sore throats, breathing difficulties. These things right now, there is so much happening in oil and gas country that it's hard to even keep track. But I love this group because they have created such a powerful tool and a powerful way to map out the harms the community is experiencing. And this is also really powerful data for researchers who come later. They can look at exactly where certain health conditions are popping up, what people are saying. It is the beginning of the scientific process here of trying to map out, trying to figure out what's happening. And that's really, I think, the main message for today. The industry, they have these, really kind of robotic documents that lay this out. The closest they'll get to a human is to do that diagram of a human, but they haven't mapped this out to the terrain in which we actually live and work. Industry regulators know about this as well. One of the slides I presented came from a conference of what's called the Conference of Radiation Control Program Directors. This is a group of industry regulators, meaning the people in the state and federal government who look after our health and the environment. So they've seen these presentations. They don't seem to be acting on it, but we now have researchers, we have health groups, and we have residents across the country here in the US who are paying attention. And so I'm now going to turn it over to them. Thank you. And so we will have Dr. Marcia Haley coming back, and she'll be speaking first.
Thank you, Justin. That was an excellent introduction. I'm just waiting for my PowerPoint to come up. Oop, that's the middle. Yeah, there we go. Great. Okay, so I'm going to be talking about a study that we performed looking at radioactivity at oil and gas sites, as well as potential health effects associated with radiation exposure. Next slide. So when we take samples and evaluate for radioactivity, we realize we're already dealing with a baseline level of radiation, like Justin said, background radiation. It's everywhere, especially when you live in Western Pennsylvania in the Marcellus Shale. This is the reason we all have to have our homes tested for radon. We all receive radiation as part of our daily lives. This chart gives a breakdown of the radioactive elements that come from uranium. The ones we are concerned about are downstream from uranium, and that includes radium, radon, polonium, and lead. Each of these gives off different types of radiation, including photon, which are X-rays, alpha and beta, which are particle radiation. Next slide. We've known for many years that radioactivity exists as part of oil and gas operations. According to the EPA, the amount of radioactivity depends on the geologic location, formation conditions, and the type of production operation. For example, the Marcellus Shale is known to be one of the more radioactive shale formations. And the leachate radium within the rock comes from two distinct sources, the clay minerals that transfer radium-228 and an organic phase that serves as the source of the more abundant isotope radium-226. The increased salinity in the water, and we know that fracking water is has high saline content or salt content. It draws the radium from the fractured rock. Radium emits alpha particles. If you remember from high school chemistry, that's 2 protons and 2 neutrons. Beta particles, which are high energy electrons or positrons, so particle radiation, and gamma rays, which are like X-rays. Next slide. In our study, we looked to evaluate the presence of radium and radon around oil and gas sites and to evaluate for the radon progeny or the downstream isotopes such as lead and polonium. Next slide. The people in this study were Dr. Bascaron from Wayne State, myself, Bobby Mannion from Wayne State. Dr. Bascaron and Bobby are in the Department of Geology. Tammy Murphy from Physicians for Social Responsibility, Laura Dagley, RN, Physicians for Social Responsibility, and Justin Noble, journalist. Next slide. Our funding partners for this study included Physicians for Social Responsibility. Dr. Walter Sau was our principal project coordinator from PSR. We also received funding from the Park Foundation, which is dedicated to the aid and support of education, public broadcasting, environment, and other selected areas of interest to the Park family. Next slide. We took radon air measurements, as well as water and soil samples from the following types of locations: creeks, public parks, wellheads, near holding tanks, runoff ponds, pipelines, compressor stations, and old waste pond sites. In the cases where we couldn't get right on a site, we sampled as close as possible. Next slide. We began our sampling in southwestern Pennsylvania and Washington and Greene counties. These are heavily fracked counties in southwestern Pennsylvania. Next slide. This is a picture of Justin at one of the public parks that we sampled, and a picture of Bobby setting up the air monitoring equipment. Next slide. This is a well pad. We were able to sample around the wellhead, near the holding tanks, and the runoff ponds. I will mention that this well was in the production phase, not in the active fracking phase. Next slide. Next, we moved over to Westmoreland County to sample near landfills that accept oil and gas waste. We were still in southwestern Pennsylvania, but moving toward the south central part of the state. Next slide. In this photo, we are sampling water and sediment downstream from a landfill that accepts oil and gas waste. This particular landfill also has a coal seam which opened up underneath it, which we explored to a very shallow depth in the right-sided picture. Previous research teams have measured high concentrations of radon in this coal seam. Next slide. I will say that at the second landfill we went to in south central / southwestern PA, 2 of our team members became ill. They felt dizzy, had a metallic taste in their mouths. At that site, we also found some trace radon readings, which was surprising because the wind was blowing. We noticed many abandoned houses near this landfill. We then moved on to southeastern Pennsylvania and the Philadelphia area to sample near the Marcus Hook refinery and the Mariner East pipeline. Next slide. Now, living in southwestern PA, I'm used to dealing with wells, compressor stations, and pipelines. However, these pictures illustrate what people are dealing with in southeastern Pennsylvania. This is an apartment complex in the suburbs of Philadelphia. The Mariner East pipeline is going right through the apartment complex. On the right is a view from someone's apartment. If there were a pipeline explosion, those people would not survive. I was just simply amazed that people are living this close to these huge pipelines. Next slide. This is a picture of our team at the Marcus Hook refinery, which is the last place we sampled. And this is the last place the natural gas is transported to. It comes from western Pennsylvania, across Pennsylvania to eastern Pennsylvania through the Mariner East pipeline. And then it goes to the Marcus Hook refinery and it is then sent overseas. Next slide. This is a map of the sampling sites and the different types of samples that we took. We took soil core samples, water samples, and soil grab samples. Next slide. This is a map of our sample sites overlaid on a map of fracking wells. You can see that the southeastern part of the state is spared. They don't have many wells in that part. That's where all the pipelines and the refineries are. Next slide. To prepare for the sampling, the soil was dried and placed into a spectrometer. Liquids were filtered and placed in an oven, then into a spectrometer. I'm not going to go into the details of that because that was done by the geology team, and that's a little bit above my knowledge level for preparation of samples. Next slide. Out of the soil grab samples, we found 2 that had high levels of radioactivity. One was from a water cistern that was felt to be lead input from precipitation, and the other was sediment that had settled from well water near a fracking pad. Next slide. These are the soil core results. None of these were above EPA limits for radiation. Next slide. These are the water sample results, and none of these were above the EPA limits for radiation. Next. In order to figure out how to translate these results into clinically relevant information, we look at the recommended dose limits. There are different radiation dose measurements used depending on whether we are measuring soil, air, water, or calculating the dose to a human being. This helps us to determine whether an amount of radioactivity is problematic. One way that we measure radioactivity is called the Curie. This is named after Madame Curie. A Curie is a large unit of radiation. So in water, we typically measure this in picocuries, which is 1/1,000,000th of a Curie. In this study, we measured whether any water samples were above the EPA recommended limit for drinking water, which is 5 picocuries per liter. We did not find any samples that exceeded this limit. We can also measure in becquerel, which is another measurement of radioactivity. This is often given in becquerel per weight in kilogram, and the maximum EPA limit is set 370 becquerels per kilogram. In our study, 2 of the samples exceeded this limit, as I discussed. The second thing we look at is dose equivalent, which measures the type of radiation and the potential medical effects. This is measured in REM, which stands for radium equivalent man, and the annual limit for a member of the public is 0.1 REM. In our study, we measured this in millirem per hour and then calculated that out to a year, and we did not find any samples that exceeded the annual limit. Alpha particles are a special type of radiation that we talked about, 2 protons and two neutrons. They have low penetration, but a high biological effectiveness. That's why radon is such a problem with breathing it into the lungs. And the dose limit for alpha is 15 picocuries per liter. Next. Our study had some limitations. The air sampling was taken in the open air during inclement weather, which affects the radon measurements. We saw some radioactivity in the creek near one of the landfills. While this was not above health-based limits, we were not able to have access to the landfill itself. In the past, this landfill has been fined for spills and leaks, has been found to have high level of contamination in the waste it accepts from oil and gas. While we can estimate the background level of radiation in the soil and water, we are planning to collect more controls that are in the same geographic region but away from oil and gas infrastructure. We were not able to obtain a flowback sample. We know by years of data in the DEP's own radioactivity study that oil and gas waste has a high level of radioactivity, especially in flowback. Another purposeful limitation in this study is that we did not examine other chemicals and heavy metals associated with a fracking process, many of which we know to have problematic health effects. Also in July of 2021, there was a major setback when Detroit experienced a state of emergency due to flooding. This was the geology lab at Wayne State was flooded, including some of our samples. The flooding destroyed some of the samples and required a prolonged time to restore the lab and resume analysis. Next slide. So the conclusions are that we came up with our study, given its limitations, were that activities and sediments generally did not contain enriched levels of radium-226, and the activity was in agreement with the upper crustal activity. Lead-210 maximum detected activity was found in those 2 samples we talked about, the cistern, which was likely impacted by washout of atmospherically deposited lead-210 on the roof of the house, and the next highest activity of sediment was in a well water tank. Activities in soil grab samples were slightly enriched with radium-226, which could be due to a high background or impacted by oil and gas activities. One of the more interesting findings was that soil core collected from the fence of a compressor station contained higher levels than expected of lead-210 as well as radium. This indicates to us that there are likely effects from oil and gas activities. The highest activities in water were found in surface waters near condensate tanks, compressor stations, and landfills. The estimated radiation exposures did not exceed the 1 millisievert per year or 0.1 rem limit set for public radiation exposure. The highest effective annual dose was 72% of the annual exposure limit. Next slide. So for future research, what we would like to do ultimately is collect more samples. We'd like to get actually on some of these sites, get permission from industry and the Waste Management Authority to actually get on these sites and provide samples. We'd like to collect samples while wells are being actually drilled. We'd like to sample fracking waste, collect more samples, collect surface water samples closer to infrastructure. We'd like to expand the study eventually to include volatile organic compounds, BTEX, as well as markers of contamination. And we like to synthesize global data on T-norm, which is technologically enhanced natural occurring radioactivity from oil and gas operations. Next slide. So as far as health concerns, this has been going on for a long time. In 1993, the Society of Petroleum Engineers published an article that pointed out that many parts of oil and gas operations have radioactive elements, including the wellhead, pumps, filters, valves, compressor stations, and refineries. There was also an analysis program developed by the CDC in 2016 in response to concerns about oil and gas workers receiving high doses of radiation therapy. And this indisputably linked the workers' cancers to radioactivity exposure received on the job. And then in 2019, Public Herald reported that oil and gas waste disposed of in landfills is resulting in radioactive leachate that is released into waterways. Their data is consistent with the DEP, Pennsylvania DEP 2016 radioactive study. Next slide. One of the challenges of studying the health effects of low levels of radioactivity is the latency period of cancer, because cancer is the thing that we worry about with chronic low levels of radioactivity. This is the time period between exposure and the diagnosis of cancer. We've actually had an easier time studying cancers from benzene and silica, also associated with fracking, because of the shorter latency period. As you can see, a solid cancer can take 20 years to manifest. Next slide. A really good case series on cancer from radium was the radium dowel workers. I'm sure you've all heard of them. They developed bone cancer from exposure to paint which contained radium. They are part of the 1 million-person study looking at health effects from chronic low doses of radiation. Unfortunately, the program was terminated in the 1990s due to lack of funding. However, there has been renewed interest in this subject. Next slide. So, in conclusion, from my portion of this talk, radioactivity is inherent in many parts of oil and gas extraction. Previous studies have found high levels in various parts of the system, as well as adverse health effects. Our study found that estimated radiation exposures did not exceed the limit set for public radiation exposures. However, some samples near compressor stations had higher activity than expected, indicating likely effects from oil and gas activities. So that concludes my portion. Thank you.
Dr. Haley, that was fantastic. Thank you. And we have some really good questions coming in, so maybe just hang around for a moment. We'll go through a couple of them before going on to the next presenter. One is, do you agree with the position that there is no safe dose of ionizing radiation?
That's a really good question, and there's a lot of scientific data on that topic. They've actually done studies of nuclear workers, and some of them actually have better health and better longevity than than controls. And so there's some thought that there might be some quote benefit to low levels of radioactivity. You know, this is an area of big controversy in the scientific literature, and we don't really have a consensus on that. But you know, that is one interesting thought. Ideally, we like to have as low levels of radioactivity as possible. As Justin and I both mentioned, there's background radioactivity that none of us can get away from. You know, if you have to go and have an X-ray, or if you have to go on a plane, you're going to get some radioactivity or radiation exposure. Our biggest concerns are in pregnant women and children, because they are much more susceptible to the effects of radiation. So those are the groups that we really try to protect. So I know that's kind of a long-winded and complicated answer, but it's kind of a nuanced question. So I hope that helped.
Yeah, and just what I see, some of the questions we're going to get to in future presentations, so I'll save them. But another question, just on when to expect health issues to emerge. I think you addressed that in some of your final slides, but maybe talk a little bit about that.
Yeah. So the fact that we're still gathering the data. DEP just brought the report out in 2016, and then the Duke study looked at sediment in the waterways downstream from some of these facilities and measured radioactivity there as well. So, when you're talking about a latency period of cancer of up to 20 years, we don't have data at this point to tell us, okay, these people developed a cancer cluster from radiation that's coming from the fracking industry. So at this point, we simply don't have the data, but it is definitely something that needs to be continued to be studied, and that's what we're pushing for.
Okay. Thank you so much, Dr. Haley. And we are now going to go to Tammy Murphy, Physicians for Social Responsibility, Pennsylvania.
Hi, how are you, Justin? Can you hear me?
I can hear you. Yes, Tammy. Thank you.
Excellent, great. Okay, well, thank you for having me. And thank you, Dr. Haley, for such a great description of our study. I really appreciate it. I am Tammy Murphy, and I'm with Physicians for Social Responsibility in Pennsylvania. And I'm going to talk to you about some of the community town halls that we're doing now that we have the results of the study that Dr. Haley just described for us. So we can go to the next slide. Just to give you a little background about PSR. We were originally founded to oppose nuclear weapons. In around the 1990s, PSR Pennsylvania shifted to apply its medical expertise to environmental health issues in recognition that global climate change and toxic pollution also pose grave risks to human health. PSR Pennsylvania addresses health harms for which you cannot write a prescription, which is sort of the same as the umbrella organization Physicians for Social Responsibility. You can move to the next slide. Okay. So after we got the results they kind of came in drips and drabs, and there was a flood, so it took a long time, as Dr. Haley explained. But now that we have the final results, we want to make sure that we give it to the community members that were kind enough to, in many cases, allow us on their property and, showed us the best food in the town, and really are wonderful hosts, and have been living with lots of health concerns. So we wanted to make sure we got the information to them as soon as we could. And it's been quite a while since we did the actual study itself when we took the samples. So now we are doing that in combination with some other work that we're doing. We're really using the town halls in two ways. One, we're bringing information about the radioactive emissions study. We are gathering in advance of each. It's a series of 5 town halls across the state, with plans to kind of maybe do some kind of activity or something in the fall afterwards with everybody. But we're basically gathering, giving information first. We're going to be providing the information from the radioactive emissions study, the sort of local results, and then we are going to be looking at the FLIR camera. So in advance of each town hall, myself and PK are going to areas where we are gathering information. She'll probably talk more about the FLIR camera, but these are images of hydrocarbons that you can't see with the naked eye. And then we're also setting up air monitoring. And we have a system, like a platform that we're using, where we can combine the sensors that we're using and the sensors that other people are using, and we can gather quantitative and qualitative input. And we're doing it in the areas where we live, where our staff lives, and then also in the 5 town halls. And we're basically trying to get a big picture of what people are dealing with. So when I say qualitative data, I mean putting in information like about headaches, nosebleeds, feeling tired, or smelling something strange. So people can kind of journal and tell us what they're feeling, and we can add things like FLIR images as we see them through the camera, or any kind of activity that we learn about. And then through the qualitative data, through the air monitors, we're able to like sort of surround a facility, for example, like the landfill that Dr. Haley spoke about. It's at this point pretty much surrounded with air monitors at residents' homes, so we can see if a plume is moving one way or another. We can see if there's spikes, what kind of spikes, what times of day. We're kind of checking for patterns. And then we have other plans in the future for those air monitors and that system as it grows. We're working with local groups. I named one here. This is WASIPA. These are the Watchdogs of Southeastern Pennsylvania. That was our first town hall that we finished just recently. And so we're pairing with local organizers and activists and doing the work in their own community. So then we give them a space to kind of talk about their issues. talk about whatever needs the community has, and then we have question and answer session, and then we open it up really as like a listening session for the community. Any kind of concerns, we're just leaving space, sort of open space in the meeting to think about ideas, to think about what they want to do about these things, or kind of whatever the community wants to talk about. And that is really like, so the two parts are us giving information and then us gathering information through the monitoring system, but then also through the listening sessions. And the idea is to go into all the communities, share all the information that we have, make everything as transparent as possible, gather as much information as we have, and then come up with a plan of how we're going to address these issues. Like perhaps we'll go to the Capitol, perhaps we'll end up going to DC, I don't know. Will it be something like a direct action, or will it be more like a legislative briefing? I can't really tell you because we haven't had the town halls. We only had the one with WASIPA, which was quite successful. That was in southeastern Pennsylvania. And, when we go through and hear what everybody has to say, then we're going to be kind of figuring out what we should be doing about things. So that's really the purpose of the town hall, to give and get some information from everybody. And then if we can go to the next slide. I don't have to do much with this slide. I was going to explain the study, but Dr. Haley did such an excellent job. We can skip over a lot of it. I do want to point out the maps here. So if you can take a look at the image, this is the state of Pennsylvania. And if you see the colorful yellow and red dots, these are industry infrastructure sites. It wraps around the state, mostly on the western side, north, and sort of, kind of takes a curve there. And if you look down at the southeast corner, there's really not a lot of drilling activity. There's not a lot of extraction. However, if you look at the following map, the one on the lower corner with the red lines, these are pipelines. So wherever you're seeing a lot, of course, where the fracking is actually happening. And also there's an ethane cracker plant on the west side. So you have a lot of transportation of this material, so the products that's coming from the fracking, and the pipelines show you how they're moving it around. They're definitely in the area where it's being extracted. And then along the bottom is a very interesting, this is the Mariner East that Dr. Haley also touched upon. There's material coming into the ethane cracker plant where the ethane is being brought up here so that they can make plastic nurdles out of it. I say here because I'm actually in that area today for some of the work that we're doing. And I usually live in the southeastern part of the state. But there's also in the southeastern part of the state, there's export and there's storage. So there's lots of movement of the product. And in the movement of the product, you end up not only with the pipelines, but also with compressor stations. So the really interesting thing about our study was we expected in the area, like on the top of the map where you see it so colorful, we expected to see higher levels of radiation. But what our study showed us was that even in these other areas that are far from the site, we were finding similar levels of radioactivity. That actually surprised us. And this was a preliminary study. It was the first of its kind. And as Dr. Haley said, we have lots of plans to do more. So we can just go into the next slide, and I'm going to talk about some of the levels of what we're seeing. Okay, so this is far from the drill pads. This is far from the extraction area. This is in the southeastern part of Pennsylvania, which to me is a very interesting finding. The levels there are higher than our background study, as they are in almost all the places across the state. They're higher than our background study, but they are lower than the legal limits. And that's a lot of what Dr. Haley talked about, the EPA standards, or there's OSHA standards for workers, the Nuclear Regulatory Commission. These standards are the legal limits, and that's what we know. That's what we abide by. So the threshold is pretty high for this compared to, if you look down at the chart, especially the last two sections, the white and the yellow, there's a drastic difference between the measurements that are allowed legally and the measurements that impact health. So the measurements that impact health, and I'm really just, to be honest, learning about this. A group called the Environmental Working Group has done a phenomenal job on this. So I'm myself. I'm just learning about it, but it's really clear. The levels of health-based concerns, the health-based guidelines are very close to detection levels. And in California, the regulations are becoming more strict and being designed closer to the health-based levels. And what we have in Pennsylvania are the legal levels. So as Dr. Haley said, there is lots of debate about this issue. This is not a settled issue. But this is a real concern of mine, because I think if you're just looking at the legal limits, a lot of times we're talking about people in protective gear, people who are doing an 8-hour shift, people who have sort of limited once in a while exposure, an occasional thing like a one-time incident. But our studies are on people's properties. This is where they live, they work, they play. And in a lot of the areas, like we saw on the map, it's so inundated with the industry, especially in the West, especially in the North, that no matter where you work, live, or play, you're going all day. You're going to see it. Your parents are going to see it. The children are going to see it. Your neighbors are going to see it. It's going to be everywhere. And although the levels are lower than the legal limits, it's a constant exposure. And it's a constant exposure that's higher than our background levels. So to me, this is quite concerning. It's not something that we can say is illegal, but to me, it's quite concerning. And if we can go to the next slide, I'm going to wrap up with what I think this industry, if it had been done properly, I think that the industry would have practiced what is known as the precautionary principle, which is when a certain activity may have environmentally harmful consequences, it is better to control and restrict that activity at the start rather than to wait for scientific evidence to prove that something had gone wrong. So you're kind of waiting until afterwards, where the precautionary principle would demand that you sort of know that it's safe before you proceed. Now we have the evidence, after all these years, that there is no way to frack in a way that's safe or healthy. And PSR puts out the Compendium every year with the concerned health professionals of New York. And it's a fantastic document that comes, I shouldn't say every year, it's updated regularly, approximately every year. But it's updated with all of the new studies. And there are thousands of studies to say that there's no safe or healthy way to frack. And so at this point, we know that. We know that people are women and children, as Dr. Haley mentioned, are the most vulnerable. Pregnant women, there's lots of stuff about maternal health. There's lots of stuff about asthma. And there's so many studies that show that it's a harmful industry. That when governments permit this, I consider it state-sanctioned violence. If another country was to put these same toxins into our community, it would be considered an act of war, because these toxins cause levels of morbidity and mortality that if another country came over to the United States and dumped it on to, say, like Philadelphia, that would be considered an act of war. You have issues of morbidity and mortality that are inescapable. The same if you're talking about a non-state actor. If somebody that wasn't a country, they came and they poured that kind of toxins into our community, into our air and our water and soil, and caused issues of morbidity and mortality, they would be considered terrorists and they would be treated that way. And if you or I did it, we would be punished. We would probably be put in jail for doing this because, rightfully so. It's going to kill people. It's going to cause illnesses that are going to last a lifetime. But when the state does it, they're allowed to do it. And the way I see that is when they permit it, I see this as state-sanctioned violence. They do these permits knowing that it's going to cause morbidity, it's going to cause mortality, and it's going to destroy properties. It's going to cause issues that last a lifetime. It accelerates climate change, which in itself brings a whole host of health hazards and other dangers. And ultimately, people are, in most cases, really not given a choice. We're often not told the true information. We're definitely not told about the health harms to the degree that we're experiencing them. And, we should be following the precautionary principle when it comes to industries like this. And we should also give people free, prior, and informed consent. So they have to know what's coming into their community, and they have to be able to completely understand it and have the free will to reject it. If they decide that this doesn't belong in our community and we don't want it, they should be able to do that. So that's what I would advocate for, is free, prior, informed consent. And for when industries like this operate, we should be operating under the precautionary principle. Okay, and I'll leave it at that.
Yeah, that's really powerful. Fantastic, Tammy. Thank you. And there's a really good question I want to put to you that came up in the last talk. But for any journalist, other interested folks who happen to be listening, really interested in following up on the science, the compendium that Tammy mentioned, it's a compendium, meaning it's a collection of all of the health studies that have looked at fracking and found health harms. So it's not the studies themselves, it's essentially a list of the studies. And at this point, it's like the size of a phone book. This is an amazingly powerful tool for anyone who really wants to look at what fracking lays out onto the human and community landscape. It's so important, and it will lead you to a lot of other information. You know, it's vital. Question along those lines, really good question. Has there been any legislative action, Tammy, to limit the amount of radioactivity produced by the industry that may harm people? Have you seen this on the state level in Pennsylvania? Have you seen this any action on the federal level?
Legislative action to reduce the number.
I think the question is really to address this issue. Have any legislators taken action that you know of to address this topic, some of the things being presented today?
Okay. I don't think that any limits have been put on like how much is allowed to be produced in the production of it. I don't think that's actually been addressed to my knowledge. In Pennsylvania, there has been, I don't think it's enacted yet. I think that it's passed, but I don't think the regulations have like set in yet. And I could be wrong about that. But I know there's been some legislative decisions to measure the landfills, the radioactivity that's coming off of the landfills, which prior to the Public Herald's reporting, I don't think that they would have, I mean, without the Public Herald's reporting, I don't think that they actually would have ever been held accountable. But Public Herald did such a good job of tracing that it really brought it to the forefront, as did your work, Justin. But I think that issue of radioactivity in the landfills, where they're putting the waste, has been brought forth to a point where I think it's still yet to come. I think they gave the industry some time, or the operators of the landfill some time to kind of make it to come to fruition. But they are going to be required to measure it, and that is new. I don't think that there's an actual limitation on it. I mean, I think that each landfill does have a limitation of how much they can take. In all forms of what they take, what they receive, but I don't think that there's a limitation necessarily on radioactivity. I think that they just are being forced finally to measure it in a transparent way. There's other legislation in Pennsylvania. It's been a real struggle to get this to go through. The Republicans are super in favor of the industry. Most of the Democrats are too, to be honest. But some Democrats are pushing for leachate to be monitored and reduced and taken care of more carefully. So there's movement. And then I know Representative Chris Rabb just recently, I think in the last month or so, put forth a bill regarding public health, and that anything that is a public health issue or will, like, in it ultimately it speaks to the precautionary principle and the idea of state sanctioned violence, as I talked about. Not that he names those things, but the idea, the essence that when the public is going to be harmed, it has to be transparent and it can't be hidden. So that kind of like, and it targets not only the companies, but it targets the agencies that know about these things. So it's a very interesting bill, and I don't know if it will pass. Like, I think it was just shared with other legislators like less than a month ago.
Okay.
And that's all that I know in Pennsylvania.
Yeah. No, thank you for that. And I'll, really helpful response. And I'll speak a bit to that, and then we'll pass it on to the next speaker. So really good question about legislation. And Tammy brings up an important point. When people, journalists, community groups spotlight these issues, even amongst agencies that have been pretty tight-lipped on this, pretty hesitant to act, they have acted. So, you see as problematic and kind of potholed as it may be, you can see the process in action, the democratic process. People raise concerns, they bring it to the public's attention, and we have seen some movement. I'll give you, though, the other side of it. In Ohio, there is now a law, not a law, trying to pass a law that would enable, make it even easier to put radioactive oil field waste on the roads. Right now in Ohio, you can do this. It is legal, but legislators in that state are so ill-informed that they're trying to remove the few restrictions there are, all in the name of commerce, and make it even easier for companies to just slop radioactive waste onto the road under this misguided notion that it will help melt snow and ice. And what they're really doing there is like the reverse of what Tammy mentioned. They're trying to like strip away rules and make it easier for business to put these harms in the public's way. And they've actually put a limit in that bill in terms of how much radium can be put on the roads. And I mean, it's astonishing. The EPA has a really strict level for what constitutes radioactive waste. If we're talking about radium, it's 60 picocuries per liter. And in this bill, they can put radium, oil-filled waste with radium on the roads that's as high as 20,000 picocuries per liter. So again, really highlighting the importance of educating your legislators and raising the public awareness. So hopefully the ones who are completely ignorant on this, won't be around much longer. That was great, Tammy. Now moving on to Christina, PK, who will follow up with another excellent talk. Christina.
Hello. Hi, everybody. My name is Christina DiGiulio. Some of you guys know me as PK. And as soon as my slides come up, we'll see who I am. But I can start talking about it. I am actually a watchdog, and I want to talk about watchdogging with y'all, and as well a little bit of a story that Justin wrote in his Truthdig article. It was pretty interesting. I'm surprised you picked it up, but I am an analytical chemist. Formerly worked for the Department of Defense, focusing on systemic prevention of environmental and occupational systemic prevention of environmental and occupational threats, basically, to populations and individuals. And then most recently, I was in I did explosives detection, and remote sensing was the focus. So now I'm here just waiting for some slides. But I'm here. Thank you. We'll just take a minute to see this. All right. So yeah, there you go. And so I'm also working with PSR PA, as you've heard several times now. And I am a certified thermographer with optical gas imaging, which obviously I think Tammy stated it pretty well. We're looking at hydrocarbons, things that our eyes can't see. And I'm supporting a wonderful organization with that work. And co-founder of WASIPA, and that's kind of like where everything started for me. Well, I was an individual watchdog, but WASIPA is Watchdogs of Southeastern Pennsylvania, and we primarily focused on the fracked gas liquids. And I have a thing with saying natural gas. It is not natural unless it stays under the ground where it naturally should be. It is, fracked gas, and with a high focus on the Mariner East Pipeline project or the Pennsylvania Pipeline project. And that is a petrochemical. It's part of the petrochemical system. So, you know, it went right through my town. So that's kind of where I ended up watchdogging. So next slide, I'm going to talk about the story, which is all about a Mariner East pump station. And this is like located. So one morning I get a call and I have a whole watchdog community and they like call me and they're like, yo, there's something happening at a pump station. And yeah, I was, you know, at home pretty much in my pajamas. And like I threw over my motorcycle gear because it was a very easy way to get out just quickly on a motorcycle and went out and I missed the flaring at this pump station. They were putting it away. And so if you go to the next slide, that's the pump station itself, what you see there. And so the flaring they're doing it's emptying, you know, the pipes for some kind of routine maintenance, they call it. Yet if you see these images, you'll see these gigantic flares. It's on the back of a truck. So a lot of people out in fracking world, they see like stable, like we have an internal flare on that pump station, but they brought this in for like massive like offload of NGL. And that's what it looks like. So when I got out there, I missed it. They're packing up the flare. And then I started riding forward to go do my normal thing where I go and check all of the sites on the Mariner East construction project. And I ended up going down a hill. And all of a sudden, my Geiger counter, which I had with me, I actually had it tied to my jacket, so it was outward, and it started beeping and flashing red at me, which I have never seen before. And so I pulled over, and if you switch to the next slide, you'll see it's pretty terrible map, but that circle there is the pump station where the you know, the source of the flare was, and you can see all these neighborhoods around here. So there's people living there. I was at the X. It's a small little X towards the to the right of the circle. That's where I ended up pulling over, which is like kind of like a gully, you know, a valley. And my meter is reading what you see there as 140 CPM, which it says high, like it literally says high on it. And I was not aware as to what was going on. I was like, this is not real. But what I realized is that there was kind of like an inversion that day. They ended up flaring and it went and dropped into like a valley. And I ended up going through what I would call a radioactive fallout cloud. And I was really upset. I rode a couple more miles and it was on me. Like it was like obviously dust particles or something because I kept checking my bike. I was irradiated. Like I was reading elevated levels than normal because I always baseline on a Geiger, meaning I read throughout an area to just, you know, get the baseline reading, which is basically the like ambient, what's going on in the area. So next slide. This is so Justin, after that I talked to a bunch of people, started getting really, I did not believe that happened to me. And Justin has been talking about this. You know, there's a lot of studies and I was shocked that it actually like happened to me. And I'm like, wow, what do I do now? I got a better Geiger counter, and thank you, Justin, for that, which I have it right here. Wonderful device. And I ended up going out to West Virginia one time. I had a friend out there who was getting really ill, and Justin always talks about the scale, which is one of the problems within the pipes. So as a watchdog, you know, some people don't get help, and they kind of call people like us as watchdogs, which I'll talk about watchdogging later in the next slide. But this person in West Virginia was desperate, and there's not much support around there. So we just became friends. I actually ended up going out there, and her neighbor, who is a Angus beef rancher, had this pig station, which is, you know, pipe inspection area. Also talked about, I believe, with Justin. It's a place where they actually open it up and clean out the scale. And there was a kiddie pool. And I know this is a video, but it probably didn't bed, so don't worry about it. Yeah, it's all right. But if you look at the picture, you can see like that's the Geiger counter in my hand. The pig station is above me, but that's a kiddie pool, a plastic kiddie pool. And that scale that you see, that's all rusty, that scale, that was there for a year, said the rancher said. And I was just like amazed. And it's on a hill, so it was like cracked and all that liquid was running down. And this video, if we could show it, I was like tracing it and shocked, like kind of scared that I even went near it. So
PK, the video isn't showing, but this is a really powerful example because this, and so I want to we're going to act this out in front of the video. I mean, this conveys the sloppiness of this industry. We're talking about an industry that just everyone saw the record profits. They got billions of dollars, right? And when they have a leak, when they have a waste stream that they want to deal with, you'd think they'd have like a sophisticated system, right? I mean, what? So they went to Target or Walmart and they got a kiddie pool.
There was a plastic bin, Justin.
Yeah,
There was a plastic bin, but there's secondary containment. Obviously, they dumped their scale into the kiddie pool, and then they put this other black bin that's above it. And it was like collected of water. So that wasn't leaking, but it was spilling over into the cracked kiddie pool. And just, it was, you're absolutely right. It is shocking to see this. And this is EQT. I'm just going to say it. That was an EQT site. Since when, so I went out there, basically what I do is watchdog. If you go to the next slide, what I ended up doing with that landowner was notifying them, giving them the data and letting them know that they have to talk to their DEP, DEQ, which is West Virginia. I think it's DEQ, Department of Environmental Quality, and also the company. And they ended up getting it paid attention to and cleaned up, which is like the most important thing for the resident who's living there. And by the way, when it's windy on a hill, any of those particulates could become airborne, which is a concern for me. I happened to be out there when it was raining, thank God. So why watchdogging? Right? This is where this all started, me going out, kind of creeping on people's land and taking pictures of, the fossil fuel industry doing their work. So it's basically about not being a bystander anymore. Like a lot of these communities who are impacted are not seeing the reaction, the DEP or EPA or from anybody that are supposed to be protecting us. And as a scientist, as I told you, I basically decided to take that resource and apply it to things I was seeing, like water testing that I saw in the Mariner East. There's terrible reporting skills on their part. We're not even legally defendable. I would say cherry picking data out of water testing, kind of what we're seeing in East Palestine right now. There is a lot of issues when they're doing like the analytical chemical testing of an impacted area. So it's a self-regulated industry. Awesome. So we should trust that. No, we have to stand up and empower our community. And the DEP has always been said to understaffed or underfunded. Of course they are, but we can then be the eyes and ears, the extension of them as, civilians. They're civil servants. So protection of, you guys can read all this. That's fine. If we go to the next slide, one of the most important things that I have learned in this, that it's like there's two parts to watchdogging. There is the individual effort, right? You got to go out there. Sometimes you're like sleeping in your car and watching grass grow, but at all times I'm documenting. The most important thing is to document everything they're doing, because you never know what you can miss. Like even if you have all this useless data, I have learned from documenting something random, time-stamped, GPS stamped, that like 2 years later, they did this weird thing. They were hiding it and I caught it on camera like 2 years ago, but I didn't know what it was at the time. There's evidence for legal cases at that time. I've been on grand juries testifying on them, and I'm working with attorneys, that are, suing because I have the evidence, and that's very important. And as well, in my residential area in the Mariner East, for example, for WSEPA, my friend Laura Snyder and I, who is my co-founder, she's in the picture below. We literally support residents because it's traumatic when you have 4 years of somebody digging a pipe in your backyard. You don't have your backyard. They're stressed out. And so what we would do is come on the property because we have the wherewithal. We have the equipment and the knowledge and know-how to go out and help them document, because they can't be like babysitting the company as well as their children and everything else in their life. So we ended up going out there, and that's how I learned how to, help residents and validate the experiences. And it really came down to health issues. So building a field team creates greater capacity for documenting and reporting. That's why we build watchdogging teams. You're not alone. Even if folks who do not have the capacity to go out in the field can be eyes and ears of the community. That's the most important thing. You have a phone, anything. So this is why watchdogging. And Justin said it to me the other day that, it starts somewhere. It might not look like science on the ground. I am a scientist, but like the stuff I'm doing, I know is pretty qualitative to try to indicate that there's a problem in an area. And this is a system that we're fighting. Petrochemical, call it anything you want. It is a system. And for us, we have to have a very, very watchful and active system that is healthy to go towards the health aspect, for example, our system has to be stronger than theirs. So, if you read it, field team members have flexible schedules and tools. There is issues with it, but every single person is a resource in your community in one way or another. And so that is where I want to end it. Like, everybody can be a watchdog. You don't have to be a scientist. You could be a data processor, anything. Like, we need a team. Remember, we're fighting a system, a toxic system, and we need to make it a healthy one.
PK, that's so powerful. And really just laying out for people how to get involved and also the beginning of the data collection process. Again, in a functioning society where the government is working to protect the people, I think they would have these systems in place. They're totally absent. And so people like PK have set up really elaborate ways to pay attention to what's happening, to tap into the community and to activate the community to look after their own health. It's incredible. And
Justin, one. It's the DEP, for example, we've seen water testing. That's how I got into it. And that's one of the things I'm certified and I've modified EPA water testing methods, right? So I'm seeing these water tests being presented by the DEP and companies. And I'm looking at like pre and post drilling and whatnot. And I'm like, they're not matching. That is cherry picking data. If they went to court, like, it's just simply as an analytical chemist, I understand the system, the laboratory information system. I know where and how it is, but they're being told this like limited, oh, my hands are tied. No, this is all you get. We didn't do this. I'm like, every water testing thing should actually look the same together. Like, it should match itself pre, post, anytime. Those reports should be, did we lose Justin? There he is.
Justin's here. No, thank you for adding that.
So I wanted to say that just because.
I think maybe we'll come back to some of these issues at the end, but that was great. Thank you, PK, Christina. And now going to move on to Dr. Detlev Helmig with really exciting project to report out of Colorado. Thank you.
Good to be back. Find my unmute button here. I would get straight into the slides, so if you could bring those up, please. Great, thank you. So this is just a small sliver of a larger study that's ongoing in the North Denver neighborhood. We are contracted by Cultivando, which is a Hispanic minority nonprofit organization. We implemented this larger air monitoring program to characterize air pollution and exposure of the community. Some of the participating groups and my collaborators are listed here on the slide, just to give credit for them, since they're doing most of the work that I'm presenting here. Back to the next slide, please. Just to show you where this is, map on the right top shows you, in Colorado, in the larger Denver metro area. Over the last 3-4 years, we've established a rather extensive air monitoring network. It's all funded by local communities and nonprofit. These colored circle on the map show these different air monitoring stations. And the one in Commerce City, the ones in the red circles, that's what we will talk about today, particularly the one that's labeled CCF. That's the Commerce City fixed site, we call it. Gives you perspective where it is in relation to Denver, Boulder on the left. The airport is just on the right edge of the map. So what I'll be showing is data from that CCF side. Next slide, please. Okay, and on the left side, you see a picture of that station. It's a monitoring trailer that contains a dozen or so different instruments for monitoring a wide array of air pollutants, and the radioactivity measurements are just a small component of that all. And in the trailer picture, in the background, circled there in red, that's where the Suncor refinery is located. You can see it is inside about a quarter mile to the south. On the right side, that's an aerial photograph of the Suncor refinery. So you can see it's a very large industrial facility. It processes on the order of 98,000 barrels of crude oil a day. It's the largest refinery in the Rocky Mountain regions, the only refinery in Colorado. produces gasoline, diesel, jet fuel, asphalt, about a third of the jet fuel for the Denver International Airport. And you can see it in the slide, it has more than 30 stacks. Stacks that go as tall as 60 meters off the ground of the surface. These stacks are reported with EPENs. These are air pollution emission notices. So there are 30 plus stacks that have permitted emissions of different gases into the atmosphere. Next slide, please. Again, that on the left, a map showing where the monitoring site is located. That will be important to remember for upcoming slides. The star there, that's the station, and the red circle is about the footprint of the refinery. So we're sliver northeast of the refinery, about a quarter mile, as I said. And on the right side, that picture that shows, an incident of emissions from one of the stacks. And what's important to realize is that even we are just 400 meters or so north of the refinery, even the emissions from the tallest stacks at times can hit the surface. It's a really nice demonstration that the stack emissions, they're believed to just get blown over people's heads, out of the urban area, maybe all the way to Kansas. It's really not consistent. This is very difficult to describe and understand and model. We've been doing some dispersion modeling as well, trying to get a handle on where these stack emissions end up ultimately. Next slide, please. Some of the instrumentation. We spent almost 6 months researching instrumentation because we wanted to monitor both gas phase and particulate phase radioactivity in real time with sensitivity that's sensitive enough to capture background levels and everything that's above, and at a high time resolution. We ended up with these instruments that are shown here in their installation. 2 instruments, one for monitoring radioactivity in the gas phase, and a second one that measures it in particles. And for the particles, we go straight to the wall. The monitor is sitting straight against the wall with a straight feed through. Since particles, you can't really pull through tubing and so forth. So 2 monitors, and the next slide, please, shows these 2 monitors that we actually obtained from a company in Germany. It took almost 6 months to get them, very challenging during the COVID days. It's the AlphaGuard radon gas analyzer on the left side, and on the right side is a second instrument that collects airborne particles on a filter and then captures the radiation released from the particles that are trapped on the filters. So both of these are operating side by side, completely independent measurements of 2 different variables: radioactivity in the gas phase and radioactivity on fine particles that are trapped on the filter. The next slide. All these data are shared, presented to everybody out there in real time on a public website. The URL is on the bottom here. You can go there right now. You can see these radioactivity measurements coming in, both from the gas phase monitor as well as the particulate readings. This is updated every 5 to 10 minutes. I'm available to everybody who's interested in following this. The next slide. The system has been running for 7-8 months by now. To give you an idea how these continuous data look like on different time scales. The top one is a day. In the center one, it's, I think, a week of data, and the bottom one is the full record. You have to look closely to see some of the features. There's quite some variability. Levels go up and down depending on the winds, on the turbulence, wind direction, wind strength. If you look at the middle graph, you can see some features in there already with your naked eye that shows radioactivity levels during that time period increase mostly during the nighttime and then come down during the day. Lots of data, over 25,000 data points by now for each of the variables. And when we go to the next slide, it becomes a little bit clearer where we now statistically analyze these data, starting out with grouping them by hour of day. On the left side, this is the gas phase radiation plotted hourly over 24 hours. On the right side, this is the radiation on the particles, and the spread for each hour gives you the distribution, where the circles show you the mean values, the horizontal bars in these boxes, the median. You can see there are very clear diurnal cycles where the radioactivity is higher during the night, building up during the night, then going down during the day. It's consistent both for the gas phase and the particles. That doesn't say anything about the emissions and the release. This is very typical behavior that we see for many air pollutants, and it's mostly driven by the mixing, the turbulence, the dilution of the atmosphere. It's much stronger during the day on average. The nighttime, when there's inversion, stagnant conditions, pollutants that are released nearby very typically build up in the atmosphere, so you have higher levels at night and lower during the day. The next slide, please. That puts these measurements in the context of some guidelines, some literature that reports typical global background air. Found a resource that listed that as 5 to 15 becquerel per cubic meters, and in parentheses of units in picocurie per liter. Now, what you have to bear in mind is comparing these measurements with what's reported in the literature, they really are additive. So you want to add the gas phase and the particles together. So if you do that, you can see our nighttime levels here are more in the order of 40 to 50, which becquerel per cubic meter, which puts us a factor of 2 or 3 above what I've seen reported as the global background. So it's slightly more than what I've seen reported in most other locations. The next slide, please. That puts the data on a monthly scale. Just wondering, the findings I'm showing right now, driven by levels being particularly high during one month, low in another month. That doesn't seem to be the case. From the 6 months of data that I'm showing here, it's pretty consistent. So we see similar levels through each of these months where we have grouped these values here. You could argue maybe a little bit less during January, February, but I think that's mostly driven by stronger winds we have here in the Colorado Front Range during those months. These winds driving a stronger dilution, and that drives levels a little bit down. Next slide, please. So what I'm going to do now, I show you an analysis we did where we correlate these measurements, and we're getting data every 10 minutes with the wind conditions at the same 10 minutes. It's very important. And that's why we really wanted to push hard to have this high time resolution measurement, because that's a very important analysis that we're doing for many other pollutants at this location. So the next slides show the result of that. So that more than 23,000 data points in each of these graphs. On the left side, it's for the gas phase data. On the right side, it's for the particle phase. That now puts the median concentration on this compass, plots it as a function of wind direction, where the top is north, the bottom going down is south, east is on the right, west is on the left, and then from the center of the plot to the outside, it shows you the dependency on wind speed. So in the very center, those are the concentration at the low wind speeds. As it gets windier, you go to the outside of the plot. So what's very interesting in these results is that there's a strong dominance of elevated radioactivity when the winds originate from a very specific narrow sector, which is just a little bit to the southwest, almost south, a little bit to the west, so roughly between 200 to 230, 40 degrees. And that's consistent between the gas phase and the particle radioactivity. And we put this here, these color plots on the map, so you can already get an idea, where's this coming from, what's upwind in that direction, where we see this increased radioactivity. Also, please pay attention to the color scale that shows you, for instance, for the particles, when the winds are from the west to the left or the north, it's mostly all blue. So their median levels are 2, 3 becquerel per cubic meters, whereas when they come from the south, they are, pretty much 5, 6 times as high at both gas phase and particles together. So when the air is transported from that particular sector, we have about 6, 7, 8, 9, 10 times higher levels in radioactivity than winds originating from other wind directions. So the next slide, please. This now puts this defined sector from where we see the increased radioactivity on the map relative to where the station is. So the station is this asterisk. The yellow lines approximately define the boundaries from where we see the elevated radioactivity, and the red circle shows the footprint of the Suncor refinery. Those two graphs on the top again, they're a little bit different. Here what we are just using, we're looking at the 10% of the highest readings, just the upper 10% of the highest values. Where do they come from? That's a probability plot, and you can see it's very narrowly defined. The 10% of the highest values come from that southwest sector, which is defined by the yellow lines on this map. Next slide, please. That now, again, we always question ourselves, is this right, or what can we be doing wrong? So here we analyze this just by month to see, is there consistency, or is it just extreme? Something happened during one particular month, but then it was different during other times. Top shows the gas phase, the low shows the particle. Done this for 5 months in a row, and you can see this is rather consistent. For each of these months, we see the highest levels of radioactivity originating from that particular wind sector. Next slide, please. That breaks up all the data in this analysis, where we look at the percentiles of the values. On the top left, it's at the bottom of the graph, that shows the 30 to 50 percentile. So the lower values, where do the lower values come from? They're not very well defined. It's mostly random. They come even from the east, from the north. And then as you go to the right and then to the bottom, and then again to the right, these percentile values go up and up and up. With the bottom right, now you see the 10% of the highest values, the 10 highest percentile values. So that's still over 2,000 measurements. So that shows the higher the levels, the more likely it is that they come from that particular sector. Whereas the lower values, the lower readings come from all over the place, but the very high values very clearly come from that particular narrow wind sector. The next slide, please. Now here we compare the source sector of radioactivity. Again, that's on the top, gas phase and particle phase, with other pollutants that we measure. Do the same analysis: hydrogen sulfide, methane, ethane, propane, and benzene. So let me point out that for other pollutants, we see very clear dominance from very different wind directions. Hydrogen sulfide comes mostly from the west. That's a water treatment plant. Propane, we see a strong signal from the northeast. There's a propane distributor right there, and we think we're seeing this. The best alignment, overlap between radioactivity and all these other species we measure, and we've done this with 10 plus different species right now, is between ethane and radioactivity and benzene with radioactivity, which you can here, these plots look about the most alike. And that's further confirmed in the next slide. That now shows correlation analysis Simple XY correlation, how strong is the correlation of one pollutant with the other. And the highest, and that's not surprisingly, and we did expect that, and that shows us that we're probably doing this correctly, is we have the highest correlation between the gas phase and the particle radioactivity. That's the top graph, where there's just a 14% residual variance. That means actually you can predict one with the other with like 86% certainty. That's really high correlation. And then what's really important here is that the second highest of everything we've monitored is ethane. Ethane is the second highest. And ethane doesn't really occur in an urban environment. It's a natural gas tracer. It doesn't have really other sources, emission releases, than natural gas sources. So that's a very strong indication for us that there's an association between the radioactivity source and whatever is releasing ethane, and ethane being a natural gas hydrocarbon. If you go down the list, the third rank is actually carbon monoxide, which is a burning tracer. The fourth one is methane. The fifth one is benzene. To me, at this time, this looks like this may be flaring, burning emissions, natural gas flaring, given there's both an association with burning tracers, but as I said, the highest one with ethane. And then I think the last slide, I think there's one more, if you could take this forward. Yes, so again, this is just a summary where things stand. This is very novel. I don't think this has been done. This has not been done in Colorado. I don't think that's been done anywhere in the United States. This high resolution, high sensitive monitoring of radioactivity in the vicinity of oil and gas refinery. And this, again, just summarizes the most noteworthy observations that we have so far. And that's my last slide. So yeah, I'd be happy to answer any questions.
Yeah, that is really fantastic, Dr. Helmig. Thank you so much. People, messaging in that they're really enjoying the presentation. Learned a lot. We want to get to the next presenter, but one really good question to get out now, and then there may be room later for more. What you're finding in terms of radioactivity emissions, how does that align with the company's permits? For example, does the refinery have permit? Are they legally permitted to emit radioactivity?
Yeah, I've been working with several community partners, and one of them has been researching these APANs, air pollution emission notices. I just checked again with her yesterday because I was wondering if that question may come up. We haven't been able to find any permitted emissions of radioactivity. So I think so far this hasn't been on the radar screen. I think the regulating agencies has not been aware of this, has not been tracking it, has not been monitoring it.
Yeah. Okay. Really, really the front lines of research. Thank you so much. And to folks listening, Dr. Helmig's site, Boulder Air, the link's been out there. You can also Google it, Boulder Air, and you'll be led to it. And this is really special because it's real-time monitoring. This is really not common for all these different contaminants, and especially radioactivity. This is totally new to have real-time monitoring. So really the front line of where the research is at these days. Thank you again, Dr. Helmig.
You're welcome.
And we will now move on to Dr. Tina Smooz, who is going to bring us back east and talk about now getting into the next section of this, bringing this type of information to the industry, to the regulators. Projects are happening in communities, and how do you try and make them aware of this and hold them accountable on this issue?
Okay, I really, I think, have a story to tell about the Mountain Valley Pipeline, because it will be a huge conduit for radioactivity through Virginia, part of North Carolina, and West Virginia. From early on, we realized that the people representing the Mountain Valley Pipeline were not fully aware of radioactivity issues. I remember going to one of the very first public information sessions they had at a local high school and asking the representatives there if they could tell me more about the radioactivity that would be associated with this pipeline. And it was really kind of funny because the three people that were there to answer our questions really started shuffling and trying to get behind one another and quickly look at their cell phones to see if they could come up with anything about the radioactivity. So what we realized was we were being told information by people that really didn't have the information that we wanted to know about. So we citizens religiously went to all the State Water Control Board meetings. And I usually did insert in my 3-minute talk the issue of radioactivity. Interestingly, we just didn't get any response from DEQ. DEQ is the Department of Environmental Quality in Virginia. I know it goes by different names in different states. When I called on the phone and talked to someone from DEQ and said, I really need more information about the radioactivity issue associated with pipeline, they directed me to their director of radon programs, which was not at all what I really wanted to talk to about that point. I already had the information about the highly radioactive sludge that would be deposited, and these people didn't. The radon expert said he had never heard of this issue and really couldn't be any help with it. So that was disturbing that the main agency that was overseeing this pipeline just were ignorant about this really dangerous problem associated with it. At the State Water Control Board meetings that they held on a fairly regular basis, we citizens would go and speak to those. And on just about every one I went to, I did bring up the issue of radioactivity. And I would get some raised eyebrows from the State Water Control Board, who are well-educated citizens that populate that board. So I had eye contact with some of them, but none of them came up to explore that really in any detail. But I made sure they heard about it. At the last State Water Control Board public hearing that was held, they did one locally here, and we had a new State Water Control Board member whose eyes really got quite big when he heard me talk about radioactivity and radioactive sludge that was going to be deposited in the pipeline. And after that session, he came by me and kind of linked fingers and nodded, but he did not have a discussion with me at that point. So impacted landowners along the path can you all hear me?
Yeah, we can.
Justin?
Hear you. Yeah, I can hear you.
Okay, there's a note saying that I'm not being heard. But so landowners, we at every possible juncture in the development of this pipeline have submitted thousands actually of comments. And there are many of us that have repeatedly brought up the radiation issue. What we have, if this pipeline is finished, is really the specter of a 300-mile-long Superfund site traversing 3 states through perpetuity, because there are no plans for, dismantling this pipeline after its useful life. And we know that it's really expensive for them to try to remove the radioactive sludge that's going to be accumulating.
I just want to provide some context as you're talking, Tina, for folks, and then ask the question back to you. So we talked about radon, this radioactive gas, which moves through the natural gas pipeline system. Radon has a relatively quick half-life, which means it's going to do what radioactive elements do. It's going to blast out a little bit of radiation. It literally loses a piece of itself and it's become another element. It's going to decay. So radon does this inside the pipeline. It decays, and then it's actually no longer a gas. It has become a radioactive metal, initially polonium, and then it will go through additional decays through various isotopes or forms of polonium, bismuth, and radioactive forms of lead. So where we're worried about emissions, that's one thing, but we also have the radioactive isotopes of radon accumulating as a radioactive sludge inside the pipeline system. And so you can't get rid of it. Either it's being emitted out the pipeline as a gas, or it stays in long enough to decay to a radioactive metal, which is a solid. And these solids, unlike radon, which doesn't tend to stick to a lot of things, these solids are very sticky. They stick inside the system. They form a sludge. And so someone asked a great question I saw in the feed on our workers exposed. This is a major risk. Workers are going to be cleaning out this sludge. And this is a real thing. You can't move a fluid through a system that's gotten gunked up. And here it's getting gunked up with radioactive sludge. It has to be regularly cleaned, sometimes on a monthly, sometimes on a yearly basis by the industry. But I'm wondering, Tina, was this in all of the different permits, was there information about the fact that that's going to be building up? Was there information about where the radioactive sludge would be taken, what landfill it's going to be disposed, who's going to clean it, what they're going to be wearing? Was any of that presented to the community?
Of course not. Nothing in their huge final environmental impact statement addresses the perpetual layer of radioactive sludge that will turn into scales. Nowhere, because I've looked through the entire final environmental impact statement. It's just not something they're addressing. So I don't know. They've never taken any action on this. They hide their heads. And if they ever thought about dismantling this pipeline, I mean, just think it would be millions or billions of dollars to safely remove that contaminant. And this is 300 miles worth of radioactive sludge and scales.
Yeah, it's just so powerful what you're conveying, Tina. And for more context, folks, the problem you just laid out, this is very real. What do you do with contaminated pipelines that have become contaminated with radioactive scale? Some of the work and research I've done shows that the industry, and this actually has happened in Mississippi and Louisiana, they gave it to schools and communities to build playgrounds. They gave it to ranchers to build fences. This is a very clever and horrific way to get rid of your waste. So I think it's appropriate to ask, what are you going to do with this at the end? It's historically been a problem for the industry, and it hasn't been a problem they've been able to answer very well. And I think this is a perfect segue maybe into Bill, who's going to follow up on, when you have this information. Tina talks about going to regulators. How do you do that? What is it? It seems like maybe an intimidating task. How do you actually try and hold an entity accountable on such a complex project? So yeah, thank you so much, Tina. And I'm going to move now to Bill, who will talk about that.
Well, hi, everybody. Thanks to Truthdig,
Wait a minute.
Zwade Kaufman, for sponsoring this event. And thank you, Justin, for putting it on. Thanks for all the experts here today. I've learned a lot, and I'm excited about that. I also want to thank Tina. Tina and I have worked together previously on other pipeline issues, including an investigation into the toxic chemicals in pipe coating. Justin has asked me to talk about the power of the written word in addressing radiation issues and the other negative impacts of natural gas pipelines. I've been involved heavily in opposing natural gas pipelines for the past 7 years. Just a little background into our personal situation. In early 2016, my wife and I learned that the Federal Energy Regulatory Commission, or FERC, had approved the Atlantic Coast Pipeline, or ACP, to directly impact our property and retirement home in Bath County, Virginia. In order to save our property, I started researching the negative impacts of the ACP and other natural gas lines. I became pretty well versed and knowledgeable about the many negative impacts. I began filing comments with FERC and writing letters and commentaries to media outlets. After 4 years of fighting what appeared to be a losing battle, we felt compelled to sell. We were sure the ACP would be built on our property. Less than 100 days later, the ACP was canceled. This was really difficult for us, and I bear the emotional scars to this day. We are not alone. Tens of thousands of our fellow citizens have been forced into defending their homes and properties against these destructive pipelines, including thousands of people right now along the Mountain Valley Pipeline in West Virginia and Virginia. They've been fighting for 8 years. I have to admit, I'm not an accomplished writer, but I'm persistent. Many other folks fighting the MVP have written extensively and much more eloquently about the negative impacts than I have. I'm really happy to be just one of a large group of like-minded people. I filed many comments on the FERC dockets for the ACP and MVP. These comments are recorded on the public record for anyone to see. Other parties fighting the pipeline may be able to use my comments in their own arguments. At the same time, the pipeline companies and their proponents have access to my comments as well. This allows them to know where I'm coming from. And if my argument is strong, that may put them into a defensive posture or even dissuade them from moving forward with the project. Matter of fact, I read an MVP comment on the docket this morning. It was in response to an earlier comment by a powerful opposition group. It appeared to me that the MVP comment was defensive in nature. They were concerned about the impact from the opposition. Another benefit of citizen comments is sheer numbers. When a large number of people file comments, they show solidarity. Recent statements by MVP indicate they are well aware of the power of citizen comments. They cited heightened opposition as an impediment to MVP completion in their 2022 filing with the Securities and Exchange Commission. I think they're running scared. Still, another benefit in filing comments is the media can read the comments and amplify those comments to a much wider audience. I've had media quote my comments on several occasions, and I appreciate that. Under the National Environmental Policy Act, or NEPA, federal agencies are required to have an open comment period for large projects where the public can file comments for or against a project. These comments have yet another benefit. NEPA requires that the agency review all comments and take significant comments into account in their decision-making process. In this case, your comments may influence an agency decision. Various states have public comment periods as well. Just this past Monday, the U.S. Court of Appeals for the Fourth Circuit vacated or struck down the West Virginia approval of a 401 water quality permit for the MVP. The court stated that MVP's prior history of water quality violations precluded West Virginia from assuming that water quality violations would not occur in the future. The court cited citizen comments with the same concerns. So in this case, public comments played a very big role in protecting water quality and in presenting yet another hurdle for the beleaguered MVP. The court heard the people and acted accordingly. And thank heavens we have 3 branches of government. Still have 3 branches of government. Let's keep it that way. I've also sent many letters and requests to the Pipeline and Hazardous Materials Safety Administration, or PHMSA. This is the federal agency that's responsible for the safety of interstate natural gas lines. I believe that MVP poses a significant threat to the public safety. Pipe safety experts agree, and they have voiced the same concerns. I've also written to and filed comments with other federal agencies, with the Virginia State Regulatory Agencies as well. Once again, if there's a public comment period, these comments are on the public record for others to see, and the agency must consider significant comments in their decision-making process. I've also filed a large number of Freedom of Information Act requests, FOIA requests, and I filed these with FERC and PHMSA. Unfortunately, most of these requests have been unsuccessful. FERC and PHMSA continue to withhold important information that's essential to full public understanding of their actions regarding the MVP. It's really frustrating. Nevertheless, even though these records have been held, there's no question that MVP is aware that I'm continuing to investigate. FERC and PHMSA confer with MVP, they're buddy-buddy, when FOIA requests are received, and they confer on many other issues as well. I've also written many letters and commentaries published in media outlets, including the Washington Post. All in all, over a 7-year period, I've probably submitted over 1,000 pages of comments, letters, requests, and commentaries. As I said, I'm not an accomplished writer, but I'm persistent, and I try to cover all issues in detail. I've tried to include as much supporting information as possible, including references. My comments are generally lengthy, and so I have concerns that the other party may not read them in their entirety. To remedy this, I've highlighted and summarized important issues so that even a quick read will adequately convey my message. I've also tried to personalize the comments in some cases so the reader better understands the negative human impacts rather than just the cold hard facts. Most importantly, I tell the truth. I don't exaggerate. Exaggeration's not the truth. If you don't tell the truth, your credibility is gone and gone forever. So I would encourage anyone who is opposed to a project, let your voice be heard and be persistent in doing so. The regulatory agencies and project proponents will know that you and others are aware of their actions. They will know that you are presenting arguments against the project and that you will remain steadfast in defending the public's right to life, liberty, and the pursuit of happiness. Thanks for letting me speak.
Phil, that was fantastic. I'd love to see a masterclass on this taught by you. Really, just great tools and a really inspiring story, of how to use the tools of the democracy one has still available and really act on them. Yeah, fantastic. And I think now maybe let's open it up. It is just past 5, so some people, some of the presenters, I know some of the audience members may have to go. We're going to be here for at least a little bit. If there are questions that have come to mind based on what you've heard that you have for anyone who has just spoken, you put it in the various ways to get the comment out. Truthdig will get it to us or to me, and I will present it back to people. One question that did come up a bit earlier, which I think is a good one, is concerning studies. And I know a bit of this, but I'm going to put it to people on the panel, whoever would want to talk to this issue. Are there studies in the works to assess whether or not the radioactivity produced by the oil and gas industry has led to cancers? Is anyone, I think the question really specifically asking, is the government or any of the agencies looking at this? Are they looking at potential links between oil field radioactivity and cancer? And I'm wondering if there's anyone on our panel who might want to talk a bit to that. Okay, so let's go to Dr. Haley. And yeah, I know she's, among others, been closely monitoring this issue.
Hi, yes. In 2019, Governor Wolf awarded $2.5 million to the Department of Health and an academic partner, which ended up being the University of Pittsburgh, to research the potential health effects of fracking in Pennsylvania. There was an update, a community town hall update scheduled for last fall. Neither the Department of Health or Pitt attended that. They said they did not have any preliminary data to share at that time. So at this point, it's my understanding they're still studying it, and we do not have any preliminary results at this time.
Okay, thank you. Yeah, and really an important study that is taking place. And I'll add that that study is taking place because of a massive groundswell of community activism, a variety of Pennsylvania groups involved in really pushing the governor to study that. And I was there the day they protested at the governor's door, and he had canceled the appointment, which was crazy. And they basically yelled at his door and you know, spoke about these issues until they eventually came out and addressed them. So, I mean, like, you know, really citizen community activism in action right there in bringing about a study. And now people, as Dr. Haley mentioned, you know, now it's, you hold the government to accountable to ensure that they actually follow through on the study, that they look in the appropriate places. The job doesn't stop. Does anyone else want to talk to that specific issue? I'm wondering, or if not, we'll let's open it up for other questions. One other question that came up in relation to Dr. Helmig's presentation is, I'm just going back to this, concerning, concerning the findings that you have observed, the data you've observed, what you've observed with other entities in the state, Colorado State, and also the industry, Suncor in this case, the refinery, who's also measuring. You know, I know there's a lot of data being taken, and how does yours compare with theirs?
Yeah, thanks for the question. So the radiation monitoring began in August last year, and as I said, you know, we've been presenting this in real time on the website, and then I've been, actually we have on the website some of these heat maps we call them that show the source of the wind direction of the elevated radioactivity, and I've given a couple, 3 presentations by now. It's been public, it's been disseminated. So far, we haven't seen much of a response or interest from the industry or the state. You know, I'm ready to have that conversation and share. Of course, you know, we do these measurements so that everybody can learn and better understand where in this case the radioactivity is possibly or likely resulting from. But so far, it hasn't resonated much with the industry or the state regulators.
And maybe from the point of view, being a scientist, is this? Is this something profound? Is this worthy of the world of science? Is this something that you plan to put into the world of science because you think it's a worthwhile result that you've observed there?
Well, I'm an atmospheric scientist. I'm a researcher. That's been my career, my life. It's a passion. And rarely do we have something in our hands that seems so exciting, that's so clean and clear and novel. So that gets me happy and excited. And of course, I want to share it. I want it to have impact. I want everybody to benefit from this. And I'm optimistic it will eventually. But this is so novel. It hasn't been done before. There's no monitoring requirement by the state. I think the EPA has this RedNet monitoring network that I think provides sampling of particles with weekly averaged data. You would never be able to see and learn what we've learned here with weekly averaged monitoring, because you cannot these concentration, wind direction, wind speed analysis, because the winds change much quicker than once every week. So, we've opened the door to a new monitoring approach, a new technology, and that's providing us different data and new insights and new interpretation. Hopefully, generating a better and new understanding of this particular pollution source. And interestingly, this was sponsored by a nonprofit. It's sponsored by a nonprofit. Similar, our work in the Front Range is sponsored by cities and counties, because I think this is beyond the current capacity that the state has to provide air monitoring and inform the public. And some of these smaller local communities and nonprofits have realized that, been unsatisfied with the level of monitoring and interpretation and information that the state can provide. And that's why they have reached out to us. And of course, we as scientists are happy to do this and work with them to bring our interest and skills at play here, hopefully to the benefit of the public and eventually the state as a whole.
Yeah. And I think it speaks so well to the idea of getting out of your silo, out of your box, of different set parts of our society connecting and enabling a project to go forward. You can't have access to the data unless you're talking to the community. You can't understand the data unless you're talking to the scientists. It takes journalists and others to process it and be able to get it out to the public. And any one of these, I think this presentation is an example that any one of these groups, you can interact with each other. You don't have to feel intimidated by the science, by the community group, by the activists, and just take the time to try to understand and realize that they have important work to offer, and it's accessible. And one question that came up related to this, and I think this is important, it's a time when people right now are feeling very overwhelmed by the state of the world, by the state of the environment, especially I think if you're following certain industries, you almost feel like the fight is too big, that there isn't hope. These industries can seem so powerful that it's that you feel like maybe it's not even worth it to lay out a comment or to pay attention. You should just pretend it doesn't exist, like they did before the plague in certain areas, and throw a big party for the end of the world. But I want to ask Bill and Tina specifically, what do you feel that there's a mental health benefit from being involved. Is that part of why you're involved? I mean, is there a release and a fulfillment that you get in just taking part? And maybe there's challenges also, but I think that's an important question on a lot of people's minds, how to play.
Yeah, Tina, if you don't mind, I'll come up with an answer on that. I think in general, it's been extremely stressful, and it's been very frustrating as well. And the reason for that is that we're not getting cooperation from regulatory agencies. They've ignored many of our suggestions and the information that we have. And we're never going to get information from the industry. They just hide that. I think PHMSA has put an iron curtain around their agency, and we can't break into it. FERC has basically done the same thing. However, if we get a little victory here or there, it's exhilarating, and that drives us to keep on working to wrong this right.
Right this wrong.
Right this wrong. I'm exhilarated right now that the Fourth Circuit has overturned the West Virginia water quality certification. And that came, as I said earlier, they just about paraphrased the citizen comments and their reason for vacating that permit. I think it's going to be really hard for MVP to get over the reputation of violate a history of violations. And I can tell you, there's more right now. They were in the EQM was involved in the big gas storage blowout in Rager Mountain. Over 1 billion cubic feet of natural gas released over 11 days. One of the biggest blowouts in our country's history. About a quarter of the blowout that occurred at Aliso Canyon in California, near the Porter Ranch subdivision. By the way, Porter Ranch residents were awarded $1.8 billion as a result of that blowout. I'm wondering if the people around Rager Mountain are going to get anything. Probably not.
Thank you, Bill. Does anyone else want to speak to that? Any of the other presenters at the mental health? And yeah, frustrating. I mean, right. It's not just like a feel better exercise. It can actually be incredibly stressful. And but like you said, Bill, the fact that the court actually cited comments in its decision is really an extraordinary, verification of your hard work. Christina, PK, yeah.
It's really weird hearing you call me Christina, but that's fine. I absolutely want to speak mental health. I'm documenting water issues, like more on the analytical science stuff. But the one thing that I have witnessed that everybody has in common, whether it be property damage, some health harm, is that everybody has been traumatized by this, and it's like sometimes like an acute issue, like continuing. And I think that one of the things we need to start looking into is like a psychological impact study that is required prior to these projects, especially in environmental justice areas, and start surveying that. I feel like, some of these scientists would have a good idea of how that data might be much different. Like, people can literally point to the thing that's stressing them out, versus like what an epidemiologist has to do, which is like very hard to, relate one facility or one to the cancer that somebody has. Yet when it comes to psychological parts, if we take people at what's going on, like, and listen, you'll find out that they are very well aware of what's causing their stress. And so I always advocate for psychological impact studies. And I've also wanted to shout out to Rachel Hood, who's doing it's called emotional geography. She had a master's thesis. It was awesome. I could share that with people if they want, but that's very important to start thinking about. It's what everybody goes through. And as climate change gets, a little bit worse, and we are seeing this hydrogen hub and CCUS coming through, we're going to get bombarded in some of these areas. And it's like, I feel like one of our protections is to acknowledge the psychological impact.
Thank you, PK. And Tina, did you want to say something as well?
No, but it just, I know it's energizing, especially for Bill and I, to be reminded of all of you folks that are working so hard addressing this issue. Because, we've been on the ground and you all are covering a lot more territory in terms of highlighting the threats. So thank you very much.
Okay, and I don't want to respect the time unless I see another question pop up. I really appreciate all of the presenters. Thank you so much for your time and different expertise. Thank you, Truthdig, for organizing. Thank you, everyone, for listening. And yeah, okay, 2 good questions coming up. So we'll address these while folks are still here. Is there an information packet targeting schools? So this is a great question. I'm taking this 2 ways. I mean, is meaning are there materials regarding the health risks aimed at schools, or are I guess I immediately go to the other side. I know that industry has created informational packets for schools. But I wonder if for someone who's maybe more in touch with the educational community, is there information, for example, the Compendium of Harms of Fracking, has someone organize that into something that's like presentable at middle school or elementary school level? It's a good question. Because I know, again, the other side has done that. I mean, they are presenting their material to children. And this has been documented in Oklahoma and many oil field states.
I don't know of anybody doing that, but that sure is a great idea. And even without getting into the nitty gritty of the subjects for kids, even the main topics, the way they categorize things would be, in itself is kind of set up to be a pretty simplified overarching issues or something, so that is maybe doable. That's a great suggestion.
Yeah, and it's also, it's, a child, I speak a lot as I'm reporting to people's children who are there, when I'm doing an interview or a talk, and you see something being emitted from a stack, like some of the slides Dr. Helmig showed. This is, there's things science needs to gather, but you can look at this and know that there is a harm right away. Material spewing out, and it's legal to do this, and then the emissions settle. Other practices in the industry where waste is injected underground, and we know very little about what happens there. So yeah, I think in a way children are better equipped to understand this because they haven't been indoctrinated into this world where it's okay to just spew emissions everywhere. It's a great question. Yeah, setback. So this is a really good question, maybe. Dr. Haley showed that really striking slide showing how close the pipeline was to an apartment complex. I know the answer to some of these things. Do people want to talk, if they know, of how close, for example, in oil and gas states, how close can a home, how close can a school be to a well pad, to a compressor station? Does anyone have that right at the top of their head, the distance, or what we would refer to as a setback? How close can this infrastructure be to communities and homes?
Justin, I can tell you that some of our local municipalities have actually, created ordinances that are talking about their stated setbacks. We have pipelines and multiple natural gas pipelines, like 50 feet from people's houses, the corner of their house. And, there's no odorant in these things. And so it's like mainly a lot of the things with schools and whatnot in our area has been set to the blast zone, like the hazard, which all of us know that like schools have. If you're near a nuclear facility, they have like training, like they have a, standard operating procedure for how to handle if there was, they do like, they practice it. But we tried to push that here in Chester County area or for the Mariner East for them to have like pipeline drills for a NGL pipeline leak, which basically we found out there's no way to save anybody. We're a recovery zone. So in that there were setbacks put it, I guess the PUC, Pennsylvania Public Utility Commission, kind of ruled on our side, and we were able, I think there's kind of this freedom to have setbacks. I think it's 1,500 feet in some cases, 1,000, but it's still like, it's not enough. Like, cause these blast zones are like, a mile. So, but they're not even, those setbacks are not even addressing the health hazards, such as like the compressor stations, or in southwestern Pennsylvania with Range Resources, what's going on with the, cancer clusters, which I think Tammy could speak to. I don't know if that helps.
No, well, really helpful. And Tammy, feel free to chime in if you want on setbacks. It's just, I know there's a really powerful example from Colorado for people who were following issues in that state where, and Dr. Helmig, you can correct me if I'm getting some of the details wrong, but tried to put an amendment on the ballot, a voter amendment, citizen amendment to push back the setback distance. So again, make, right now industry can build things very close to humans, and trying to push that back just a little bit. And the resistance by the industry was absolutely massive. And all this community is doing, all the state was doing in this case, is saying, following some of the science, we are concerned that people are living too close to infrastructure. Let's try and put a limit on how close people can live. And of course, that curtails the amount of development you can do, because then you wouldn't be able to build something very close to someone, and suddenly you lose a lot of territory. And the industry reacted vigorously to that. In Ohio, I visited a site where there is an active frac pad, maybe I'd say it's probably less than 500 feet from a preschool. And this is something that when it was in development, you would have had tanker trucks of chemicals, massive flares, emissions, and that's just a complete collapse of the regulatory system when you can have a preschool, within visual distance of a frac pad. So yes, setbacks are a really important issue, and a way to try and hold the industry accountable, as people tried to do in Colorado. I know that fight wasn't, people haven't given up on that. So it's a really, it's an important idea. How close can you be to these things? Yeah. I think I know people can learn about the topic via the Truthdig website, which announced this. We're all up there. Our information is up there. And the article I initially wrote is up there on Truthdig's site. And we're all fairly easily accessible. So thank you so much to everyone for listening in, for taking the time. And hopefully we can continue the conversation in different ways. Appreciate you all.